Now we're going to do question 1 of this prelim paper. In question 1.1, we are asked to solve for x. So 1.1.1, we are asked to solve for x for this problem here. So the first thing we're going to do is we're going to factorize this problem here. So we're going to find the factors of x squared, which is x and x, and the factors of 27 such that they give us the middle term. So it's going to be 9 and 3, right? 9 times 3 is 27. So the bigger number takes the sign of the middle term, which is negative, and this will be positive. So it's equals to 0. So after finding the factors, we're just going to equate our factors to 0. So it's x plus 3 is equals to 0, or x minus 9 is equals to 0. And then we transpose the 3 to the other side and the 9 to the other side. We have x equals to minus 3. Or x is equals to 9. So these are our solutions of x for this problem. Now 1.1.2, we are asked to solve for x for this problem here, and our solution must be correct to 2 decimal places. So since we are told that they must be in 2 decimal places, we know we have to use quadratic formula, meaning that we cannot factorize this problem here. So the quadratic formula is x equals to minus b plus or minus root of b squared minus 4ac all over 2a, right? So, but we first need to write this 2 plus x into standard form, right? Equals to 4x squared. So we're going to transpose the 4x squared to the other side. We have minus 4x squared plus x plus 2 equals to 0. And then if we divide by negative 1, both sides will remain with 4x squared minus x minus 2 equals to 0. So this is our standard form of the equation. So we're going to substitute it in this quadratic formula, which will be minus into our b, it's minus 1, plus or minus root of our b is minus 1 squared minus 4, our a is 4, our c is minus 2, divided by 2, our a is 4. So the solutions of x that you're supposed to get, it's x is equals to minus 0.59, or x is equals to 0.84. So these are the solutions of x that you need to get for this problem here. So now we're going to do 1.1.3, right? So we're going to solve for x for this problem here. So we're having the root of x minus 2 all squared is equals to 1, right? We can solve it many ways. We can expand this expression here and find the product, or we can simply use the square root. So let me just use the simpler method, which is to just put the square root. So we're just going to put the square root here and here, and then we will have root of x minus 2 is equals to plus or minus 1. That is the solution of the square root of 1, right? And then we'll transpose the minus 2 to the other side. So we have the root of x is equals to plus 2 plus or minus 1, right? And then solutions of x would be the root of x is equals to 2 plus 1, or the root of x is equals to 2 minus 1. And if you add these, you're going to have root of x being equals to 3, or root of x being equals to 1, right? And then because we want the solutions of x, we're going to square both sides. Even here, we're going to square. And then here the solution of x will be equals to 9, and here or x would be equals to 1. So these are the solutions of x. Now we're going to do 1.1.4. So we're having this problem here and we're asked to solve for x. Please note that there's an equality sign here. So we're going to have x squared plus x minus 6 greater or equals to 0. First step is to factorize. So we're going to factorize and find factors of x squared, which is x and x. Find factors of 6 such that they give you the middle term. So it's going to be 3 and 2, right? The bigger number takes the sign of the middle term, and here it's going to be negative. So your critical values is going to be x equals to 2 or x is equals to minus 3, right? So these are your critical values, not your solutions of x. So what you're going to do is you're going to draw your number line and present your critical values. So you have your critical value of minus 3 and your critical value of 2. So let me write critical value, critical value. So what you're going to do is this: you're going to test values before your critical value, in between your critical value, and after your critical values, right? So you can choose any numbers. Let's say, for example, for this case, you're going to choose -4 because it's below -3, and you can choose here 1. So these are your numbers that you can test in your equation, or you can choose 1 here, which is after the critical values. So what you're going to do is you're going to substitute these values in this equation here. Right? For example, you're going to say x is equals to -4, and then you substitute it in this equation here and see the solution that you're going to find. What's mostly important is the sign of the solution, right? We want to know the sign, not necessarily the number, right? So when you substitute this value, x equals to -4, you're going to get a solution that is positive, right? So it means now that numbers below this critical value of -3 is actually positive. So the solutions of y are positive just below -3, right? And then you're going to test this value of 1 here and substitute it in this equation here, right? And you'll find that the solution will be negative, meaning that values between -3 of the critical value and 2 will give you solutions of y that are negative, right? And then you're going to do the same thing. You're going to test this value here of 1, and you will find that the solution is positive. So the solutions of y are positive. So how do you know that you need to substitute these values, or how can you conclude now that we found the solutions of y that are either before or after our critical value? How do we find or conclude the solution of x? So we're going to look at this inequality sign here. So sorry about that. So we're going to look at the inequality sign. So the inequality sign says that we want solutions of x such that the solutions of y are greater or equals to 0, right? So what that means is we want the solutions of y to be positive, right? So what are the values of x when solutions of y are positive, right? So where are solutions of y positive? They're positive here and they're positive here, right? So meaning that your x values in this point here will face the positive side. Even here, they will face the positive side. So your x values will face the positive side, right? So how we conclude, we're going to say when x must be less than or equals to -3. So when x is less than or equals to -3, it gives you positive solutions of y, right? Or x must be greater or equals to 2. So when x is greater or equals to 2, it gives you positive solutions of y. So now we're going to solve 1.2, where we are asked to solve for x and y simultaneously using the following equation. So we have this equation and we have that equation. So our equation 1 can be 4x plus 2. Label it equation 1. Equation 2 can be 2 plus x, x plus 1 equals to y plus 12, right? It can be equation 2. So if we check, we can simply substitute this equation 1 here where there's y, right? Sorry about that. So you can substitute this equation here, just here. So you can simply write 2 plus x and x plus 1 is equals to, so where we see y, we're going to put 4x plus 2. So it's going to be 4x plus 2 plus 12, right? And then we'll have 2 plus x, x plus 1 equals 2. So if we add these, we're going to have 4x plus 14, right? And then here we're going to find the product using FOIL method. We'll have 2x here, and then these 2 multiplied by the 1, we have plus 2, and the x multiplied by the x is x squared, and the x multiplied by 1 is plus x equals to 4x plus 14, right? and then we add like terms. So it's going to be x squared plus 3x plus 2 is equals to 4x plus 14, right? And then you transpose everything this side to the other side. We have x squared plus 3x minus 4x plus 2 minus 14 equals to 0, right? So it's going to be x squared minus x, which going to add these two, so it's going to be minus x, and then these two here is going to be minus 12 is equals to 0. And then we factorize this problem here, equate to 0. So the factors of x squared, it's x and x. The factors of 12 such that they give us the middle term. We can use 4 and 3, right? And the bigger number takes the sign of the middle term, which is negative, and here it's going to be positive. So x should be equals to minus 3, or x should be equals to 4. So these are the solutions of x, and then we will use this equation here to find the solutions of y. So when x is equals to minus 3, what is the solution of y? It's going to be y is equals to 4 into minus 3 plus 2, so it's equals to minus 12 plus 2, which is equals to minus 10. So the solution of y is minus 10. The second solution of y, so let me erase here. So the second solution of y is going to be when x is equals to 4, right? This is another x value which we found here. The y is going to be equals to 4 into 4 plus 2, right? So which is 16 plus 2, which is equals to 18. So the solution of y is 18. So now we're going to do 1.3, where we are given this factorial of 10 being equals to the factorial of a, factorial of b, and factorial of c, where a is not equals, where a is not equals to 0, b is not equals to 0, c is not equals to 0, right? Determine the possible values of a, b, and c. So we have 10 factorial, right, which can be written as 9. So we have 10 factorial, right, which is equals to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's how you present this factorial, right? So what you can do here, it's all about manipulating, right, to make sure that we have 3 factorials at the end. So what I'm going to do is this. I'm going to break down this 10, 9, and 8, right? It's possible to break them down, but it's not possible to break down this 7, right? So hence I'm just going to break down this 10, 9, and 8, just to simplify it further. So to get 10, you have to say 5 times 2, right? And then to get 9, you have to say 3 times 3, and to get 8, you have to say 4 times 2, right? And then you multiply the 7, this part here, times 6 times 5 times 4 times 3 times 2 times 1, right? So what I'm going to do, I'm going to group everything. This 7 times 6 times 5 times 4 times 3 times 1 is going to be 7 factorial, right? And then this 5 and 4 and 3 and 2 will be 5 factorial. It's going to be 5 factorial, this part here, except this one here, because we already have 3, so it's just going to be this 5, these 2, these 3, and this 4. So we remain with this 3 here and this 2 here, which both of them, they can be 3 factorial, because 3 times 2 and then times 1. So we now have factorial of 3, factorial of 5, and factorial of 7, right? So we can simply say factorial of 5 multiplied by factorial of 3 multiplied by factorial of 7. So this presents the value of a factorial, this presents the value of b factorial, and this presents the value of c factorial. So we are done solving this problem here.